Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, we'll go through this combined science, which is available as this Cambridge International curriculum or even that Cambridge IGCSE curriculum. So combined science is taken by 14 to 16 years old around the world. Typically, people who take combined science, you would know that 3 natural sciences basically combined into one subject. So what we have here, this is about rate of reaction, how fast reaction is going. So this student is going to investigate the rate of reaction between a metal and an acid, and this reaction will produce hydrogen gas. Just a brief recap. As you know, metal plus acid back in year 9 combined science curriculum, this will give you something called metal salt, and they will also give you hydrogen gas. Hydrogen gas is present as a molecule, which is H2 molecule, and this thing as a salt here, you have learned about it when you learn about naming. You get chloride salt if you have HCl, which is your hydrochloric acid, give you a chloride salt. And then when you have H2SO4, which is sulfuric acid, what you will get is something called sulfate salt. And when you have HNO3, what you will get is something called the nitrate salt. Okay, so these are called metal salt. So the name with it, you have the metal itself, so it will be metal chloride, metal sulfate, metal nitrate. If your metal is sodium, you will get sodium chloride if you have sodium reacting with hydrochloric acid. If your metal is magnesium, magnesium plus sulfuric acid will give you magnesium sulfate. If you have zinc, zinc plus nitric acid will give you nitrate salt, so it will be zinc nitrate plus hydrogen gas here. Okay, so what we have here is copper reacting with hydrochloric acid, and they will produce you hydrogen gas. So this is the technique here, the investigation involved, measure the volume of hydrogen gas produced every minute. Okay, so 1 minute is 60 seconds, so you're going to measure the volume of hydrogen there. Now this student has made a couple of mistakes. Describe 3 mistakes. So describe me, you gotta talk more about saying this is mistake. No, you gotta talk about why or how is this a mistake. Okay, so describe involved, elaborating or stating, not just stating, but explaining in greater detail. That's why 2 lines for every mistake here. If you're collecting a gas, so the gas will give you bubble here, but then when you're collecting the gas, you could see that the gas can escape there. So hopefully you can see that this thing is wrong because you need to seal up that thing there. Otherwise, the gas that you wanted to collect, it will just escape from the side here. Mistake number 1, the conical flask. So this thing is the conical flask. So the conical flask is not sealed. Meaning to say you don't have you're not closing it with a lid or with a rubber bunk. It's not sealed with a rubber bunk. So rubber bunk, because these are glassware, you don't put metal on glass. Instead, you have a rubber bunk that prevent the gas from escaping through this conical flask here. Okay, therefore gas can escape. Therefore, the hydrogen gas can escape. As for the second mistake, if you look on the far right of the collection apparatus, this gas will bubble through and you will see bubbles, but then you're not collecting it inside the measuring cylinder. Instead, what you have there is this measuring cylinder is way above the level there. By right, it should be further down, immersed in the water such that the bubble will, produce the gas, and there's where the gas come in and it will displace the water and the water level will come down. So that thing there, the measuring cylinder should be immersed. There one mistake. So the measuring cylinder is not immersed in the water. There is a mistake there. Okay, so the measuring cylinder is not immersed. Immerse means you dip it into the water, into the beaker containing water. So the gas is not collected. So no gas is collected. Okay. So another very, very common mistake is this thing here. You want to collect gas. We want to collect gas, and gas is not the liquid. So, when you produce the gas will fill up the atmosphere here. Here you had dipped this delivery tube. So this delivery tube must be above the water level, must be above the acid level, such that it's the gas that will pass through the delivery tube and not the hydrochloric acid there. Okay, so that's the third mistake there. So what do we call this? The delivery tube. Okay, the delivery tube has been immersed into the solution in the conical flask. There is a mistake there. So the delivery tube is immersed, or you can say is under the level, under the hydrochloric acid level. Therefore, it cannot gather, or it cannot gather or cannot collect the gas as it intends to. Okay, last but not least, when you have done more of year 10 or year 11 combined science chemistry, you will learn that copper is an unreactive metal. So copper is less reactive than hydrogen. So this is actually a fourth factor. So there are four possible factors, four possible mistakes here. You could use this one for either of these three and you will still get the full 3 marks there. So copper is less reactive than hydrogen. So copper does not react with dilute acid. If it does not react with dilute acid, that means you are not going to get any gas out of this reaction. So no hydrogen gas, or you can say in words, no hydrogen gas gets produced, so you're not collecting any gas here at all. So for the next one, so this teacher corrects the apparatus. So now based on the correct setup, this student can measure the volume of hydrogen produced. The student add an excess of metal. When you have excess of metal, that means metal is not used up. So that means you have more than what you need. It is not used up, you have more than what you need. More than what we need, more than what we need to react. So that means the acid is used up. So therefore, the acid is used up, or we can say the acid reacts completely. Oops, my handwriting is not very good there, but it reacts fully. There's another word you can say, fully or completely. And we're going to measure the volume of hydrogen produced every single minute. So this is the graph from this reaction. So she drew a graph of her result. This is shown as line 3. So this student result is line number 3. So that is the student result. So I'm just circling it so that we know this is the student result. She repeats the experiment, keeping everything the same. This is very, very important. She kept everything the same except the temperature. She decreased temperature. So we know that temperature, as temperature decrease, rate will decrease because particles will move slower. Particles have lesser kinetic energy, so they move slower, they collide less frequently, and therefore rate of reaction will decrease there. So now, which graph will represent that thing here? Which graph will be obtained when the temperature of the reaction is decreased, and then explain your answer. So I already kind of explained it in terms of collision theory. As temperature decreases, so we know about rate of reaction, okay? So as temperature decreases, according to the questions, we gotta explain. So we gotta explain in terms of the energy of the particles. Particles have lesser kinetic energy. Kinetic energy is to do with movement energy. So when you have lesser kinetic energy, they will move slower. They move quite slow, therefore they collide less frequently. And when they do collide less frequently, rate will decrease. That means your reaction will slow down. So if number 3 is the original temperature, you want the reaction to be slower, we can think about the gradient. This is called gradient. So I'm drawing a tangent. So this is like a straight line at t equal to 0 for this line number 3. So this is number 3 there. In terms of steepness of the slope, it could be 2 or 4, but not 5, because we want to have the same volume of hydrogen. So same volume of product. Why? Because we haven't changed the amount. We are just changing temperature. Everything else the same. If you read the question, everything is the same except temperature. So temperature does not change how much product you get. It simply affects how fast or how slow. If I go to the bottom one, if I go to number 4, you can see that this is my tangent. There's number 4 there. If I draw another one, which is the pink color one, so this is number 2. So this is the tangent for number 2. Tangent refers to these straight lines, and you can calculate gradient. You can calculate gradient of a straight line. You can hopefully see that going from 4 to 3 to 2, the gradient becomes steeper. steeper, S-T-E-E-P-E-R. So steeper gradient would mean faster rate of reaction, because over the same period of time, you get a lot of gas being produced compared to these. That's why this is the fastest rate of reaction. You're just changing temperature. You go to lower temperature. As I mentioned, lower temperature, the rate will be slower. So we want the slower rate. 3 is your original experiment by the student. So it has to go to 4, where I produce the same amount of product, but it is slower than experiment 3. So 4 must be the answer we are looking for there. Now she repeats the experiment again, but this time concentration of acid is double. Is it double? She doubles, okay? So times 2, getting higher by 2. And we remember the metal was in excess. So metal is not used up. If metal is not used up, according to the question earlier, because you know how to read the question, it says excess of metal. So that means the acid is used up. So that means the more we have of the acid, the more acid particle there is, and therefore they can collide more frequently. Therefore, I should get double the rate. But remember, the acid is used up. So if acid is used up, there are more acid that is being used up. So more acid is being used up. Therefore, you get more hydrogen product, which is your volume of the gas collected. Now, she plot a graph of this result on the same grid. You would definitely get double the volume. So there are 2 reasons here. So the metal is in excess. So the metal is in excess according to the original question. So therefore, acid is used up completely. It's used up fully. So I use simple words, okay? So double concentration of the acid. Double concentration of acid will double the volume of gas produced. So we are looking at doubling the volume of gas produced. So looking at that, we can be sure that, you know, it will not stay here. It will not halve the volume. It will definitely double the volume. And as you could see, it's also faster. If I draw another line, if I use the black color one, so this has to be the gradient for line 1. So it's faster than line 3, but it also produces more gas. So you also get more product, more hydrogen gas product, because you use more concentrated acid. As the acid is totally used up, more concentrated acid, more hydrogen product. But it's also faster. As you can see, the gradient is steeper. If you compare 3 to 1, it is a steeper gradient. So S-T-E-E-P-E-R. So steeper gradient would mean faster rate of reaction there. So 2 important factors there. With double the volume as gas produced. The second factor is that more concentrated acid. So we can say more H plus particles collide. Therefore, faster rate of reaction. So that has to be line number 1 there. Okay. Now, how about the next one? She repeats the experiment again, but this time the metal is ground into a fine powder, keeping everything else the same. Everything else is the same. Remember, the metal is in excess, so it doesn't matter. You are not changing the amount of the metal. As long as the amount of the acid is the same, there will be no change in volume. So no change in volume of the gas. No change in volume of gas produced compared to the original experiment, because we have not used more acid, because the metal is in excess anyway. Metal is in excess, metal is not used up according to the question, because we know how to read the question. But then fine powder would mean bigger surface area. Therefore, you know, you have greater contact area. So we say greater surface area for the reacting particle. For reacting particles to collide more frequently. So getting straight to the point, greater surface area for reacting particles to collide more frequently, and therefore the rate of reaction will be higher. So rate increases, but you still get the exact same volume of gas produced. So we are looking at same volume of gas being produced, so it has to be there. So it could be 2, 3, or 4. It will be faster as we go to the ground metal powder. So 3 going to 2 is entirely possible, because it's faster, but it still give you the same amount of product there. So 2 could be used again. as you use a fine powder there. So it has to be 2. Actually, they're not looking for the line, they're looking for the volume of the gas produced. So realistically speaking, I have already answered that. No change in the volume of gas produced. So I could just copy that over on that side. And I could just, blah, blah, blah. I could just put my answer there. So as the metal is in excess, not used up. So I have really answered the question. I mean, I just didn't realize that they weren't asking for the line. They were asking for the explanation instead, okay? Anyway, so I've just moved things around, so that is all good. Now, at the end of the experiment, you have a solution remains in the flask. A solution means you see through. So it's transparent. That's because everything's soluble. So you have a soluble salt because metal plus acid give you a metal salt. Soluble metal salt in water. This is a mixture. How do you get soluble stuff out of water? How can she obtain a salt from the solution? You may include a label diagram. This is called crystallization. We are going to do crystallization. This is back in year 9. Year 9 separation technique under combined science chemistry. So year 9 separation technique. So what you have is you would heat up the salt. So I will have Bunsen burner. So I have Bunsen burner. I will have my tripod stand. And then I will have my wire gauge. And then I will have my evaporating dish. So these are all in year 9. Year 9 combined science chemistry. So what we have there is we have a solution. So this is the solution. Okay, so in terms of crystallization, there are a couple of important things. So stating you use crystallization is not enough because this is described. Okay, so the first thing you do is heat the solution until it is saturated. Heat the solution until it becomes saturated. This is a very, very important step. Saturated solution means it's already the maximum amount of solute that can dissolve in that amount of solvent at a particular temperature. And then number 2, leave the saturated solution to cool. And then crystal will form. Leave it to cool down. And then crystals will form. Crystals will form. And that's it really. So you just want to obtain a sample of the salt. It's only 1 mark, so you can go very directly. So what will happen is you will have crystals and you can still have a little bit of the saturated solution. So when you let it cool down, these are crystals and crystals will form. And how you can obtain the crystals? Well, you can filter it. So this will be your filter paper. And then on your filter paper will be the crystals. So you collect the crystals on the filter paper, and this is called filtrate. These crystals are basically the residue left behind on the filter paper. That is what you call a filter funnel. Okay, so the last step there is filter the crystals. Filter crystals, wash it. Okay, wash it with cold water, cold distilled water. All right. Now, very last thing, describe how she can test the gas to show it is hydrogen. So this is a test for hydrogen gas, H2 gas. Remember to include the result of the test. So to test for hydrogen, you use a burning splint. A burning splint is the one where the fire is still on. You still have the fire, you still have the flame. This is called burning splint. And then what is the result? The burning splint will go off, meaning to say the fire will go off with a pop sound. That is very important. It burns with a pop sound as you are producing water because the hydrogen reacts with oxygen and they give you water. The burning splint will no longer burn, but it will goes off with a pop sound. That is the number 1 test result. the identity of hydrogen can be confirmed when the gas burns the burning splint with a pop sound there. Okay, so this is the end of this tutorial work 1 for this combined science rate of reaction work 1 again. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel, and follow me at ptet.chemistry. There's at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. Thank you for watching. I'll see you in the next tutorial video.